Uh, Students, today we shall discuss the concept of soil-water potential. In fact, this concept is very important to understand soil-water dynamics. Basically, if I ask this question that this is the soil profile and water is entering in this soil, once it enters the soil, the question is, will water move from A to B or B to A? Now, as a layman, everybody will say water will move from A to B, but this is not true. Water may move from A to B or B to A, depending upon the energy level. If energy level is higher at A, water will move from A to B. If energy level is higher at B, it will move from B to A. This is a universal concept that everything flows from higher energy level to lower energy level. So basically, that energy level of water at this point or at this point or any other point in the soil is called soil-water potential. Now let us understand what this soil-water potential is. Now we know that if water is free, its energy level is maximum. Let us assume that this is a container having water in it. Our assumption is that this water is not attracted by any point in the container, though the molecules of the wall of the container, they are attracting the water molecules. But let us assume that the water has free energy level, its energy level is maximum. Its free energy is maximum because it is not being attracted by anything when it is contained in this container. Now, here is your soil profile. So what we do is that we transfer a small amount of water from this container into the soil. Now what will happen that here we have soil particles. So let me explain this concept like this. This is one soil particle, this is another soil particle, and this is another soil particle. So these are soil particles, you can call it as soil solids. And in between these soil particles, you have spaces. Now when water enters into the soil, this water is immediately attracted by the soil solids. So these soil solids, they attract the water molecules, what we call as Wonderball forces of attraction. So water will be held strongly by these soil solids. If I say that if this is one soil solid or soil particles, you know that soil solids, they are charged like this. They have net negative charge, but the charge may be positive or negative. And you also know that water is a bipolar molecule. So if it is positive, negative end will be attracted towards it. If it is negative, positive end will be attracted. So these are the water molecules. So this will be one layer. Similarly, you have another layer. Likewise, so this first layer, it is attracted by the soil solids with a force as high as 31 atmospheres. And you know that atmospheric pressure is 1 atmosphere, and that pressure is enough to keep blood in our veins. If pressure reduces, atmospheric pressure reduces, the blood in your veins tries to come out. And you can imagine that if 1 atmosphere pressure is enough to keep blood in our veins, what about 31 atmosphere of the pressure with which this water is attracted with towards the soil particles? And this water is never available to the plants because plants cannot expend so much of energy to take up this water. So as you move away from the soil surface, the force of attraction or energy with which water molecules are attracted, this goes on decreasing. Then you have 15 atmosphere. We call this water as hygroscopic coefficient. We call this water as permanent wilting point. If the water in the soil reduces to this level, then the plants will permanently wilt. Then you have 0.3 bar, what we call as field capacity. So this is the amount of water present in the soil which is available to the plants. So in this way, the water is being attracted by the solid particles once it enters the soil. And now this water which was transferred into the soil, its free energy was maximum. Once it was attracted by the soil particles, its free energy got reduced. So here, free energy of water, it got reduced simply by attraction. And here, ultimately the pores will get filled up, and once the pores get filled up, then if this is point A, this is point B, this is point C. Now the question is, again the water will move from A to C or A to B. It will depend upon the energy level at A or B or C. So the decrease in free energy because of the attraction of water molecules by the soil particles, we call this as soil metric potential. And here, let me explain you what is this word metric. This came from the word matrix. Matrix means soil solids plus soil pores. This is your soil matrix. So because of reduction in free energy of water by attraction of soil particles, we call this as soil metric potential. Metric word means soil solids plus pores, and potential is nothing but energy. So if I need to define this, can I say that this is soil metric potential is the energy with which water is held in soil pores, or better I should say in soil matrix. So this is one component of soil water potential, and this is always negative. Soil metric potential is always negative because when water enters the soil, the free energy gets reduced. And we express this soil metric potential as psi m. So this is one component. Now, second thing is, supposing that this soil is saline also, and there are some solutes present in the soil. Now when water enters into the soil, not only it is attracted by the soil solids, soil pores, but it is also attracted by the solutes present in the soil. Because the salt particles, they attract the water molecules towards them, so we call it as solute potential. Many times we also call this as osmotic potential and represent this as psi O. Now this is always negative because again, when something is attracted, water molecules are attracted by the solutes, its free energy gets decreased. This is also negative. So this is the second component, solute potential. Third thing, it depends upon that whether the water is present at A or whether the water is present at B. Now because this is near to surface, this is in the deeper point. So you know that everything is attracted by the gravitational potential, gravitational pull of the earth. So naturally, if this is at a higher point, this is at a lower point, so water will flow from A to B if the metric potential is same, solute potential of the 2 points is same, then the water will move from A to B. So we simply call this as gravitational potential. And now if you will ask me whether it is positive or negative, so I will say that it can be negative, it can be 0, it can be positive. Now let me explain that how it could be like this. So first of all, I will say I'm standing over here at this point, and I'm being attracted by the gravitational pull which is present in the center of the earth. We call it as gravitational pull present in the center of the earth being round. Now the question is, the distance between me standing over here and the distance at the center of the earth, this is too much of distance, so we can't measure it. What we do is that we select a reference level. You can select a reference level at any point, say over here. So we say that this is reference level, and if your point is below reference level, then it will be negative. If your point, this point A is present over here, then it will be 0, because the point is at the reference level itself. If it is above the reference level, then it is positive. So it depends upon the reference level where your point is. Now, because we are comparing the 2 points, so it doesn't matter that change in or difference in gravitational potential. This is in fact indicated by psi g. So this difference in gravitational potential, it will remain the same whether your reference level is present over here or over here or over here. At any point, difference will remain the same. So then there could be another thing. Supposing temperature over here is different at point A than at point B. So that means then there will be one more energy level, which is, but we assume that the temperature throughout the soil profile is more or less same. There are very negligible differences in temperature. So these are the main 3 components of soil metric potential. So in other words, total soil water potential is equal to sum of metric potential plus gravitational potential plus osmotic potential. And if your soil is non-saline, then even this component will not be there. In case we can remove this component if your soil is non-saline. So mainly the movement of water in the soil is governed by these 2 components, and ultimately it is the total soil water potential at the 2 points which determines the direction of flow of water. Now, if I have to now define this total soil water potential, how will I define it? So very simple. Total soil water potential, we denote it by psi t. This is now the amount of energy used to transform a small quantity of water from a pool of free water. So this is pool of free water. Instead of free, I should say pool of pure water. Pure, when I say pure, it means without any salts. So in bracket I will write having maximum free energy, having maximum free energy. So this is the definition based on this concept which I explained you. In other words, in a soil I should say total soil water potential is the energy with which, I should say energy level, with which water is present at a particular point in the soil. So this is very simple definition, no need to cram the definition from the books. So I explained this through this schematic diagram. Based on that, this is the definition, otherwise this is the definition of total soil water potential. Because it is the energy level, so we define this, the units are defined, units will be in centimeters. So when I say that total soil water potential at A total soil water potential at A, so it is 3000 centimeters, and total soil water potential at B is 1000 minus 1000 centimeters. So that means difference in total soil water potential at A, simply difference in total soil water potential will be 3000 minus 1000, so this will become 4000 centimeters. And if I divide this by L, L is in fact the distance between the 2 points. So say it is 50 centimeters. So 4000 divided by 50, this comes out to be 80 centimeters. So we call this as hydraulic gradient. Gradient means difference. Hydraulic means the energy level due to water. So difference in the energy level due to water at the 2 points, this is called hydraulic gradient, and this is simply the ratio of difference in total soil water potential at A and B divided by the distance between the two. This hydraulic gradient determines the speed with which water will move. The flux, we also call this as velocity. You can also call that velocity. We will discuss that in our next topic, that is Darcy's law, which explains the basis for movement of water in the soil. Many a times, instead of writing these long figures, I can write total soil water potential as 3000. I can also write it as, if I take log of 3000, it comes out to be 3. It comes out to be 3. You can check, I don't know whether it is 3 or what we write is, I think it should be 1, 2, 3, 4 point something or 3, I don't know exactly, I'm sorry for that. You need to check that what will be the log value of 3000. When we write the log value, negative log of this, we call this as PF, small p, capital F. Just like pH, you say pH is the negative log of hydrogen ion concentration. Similarly, in soil water potential, this is negative log of total soil water potential. Very simple. So this is just to write the value. Then another thing which I would like to explain over here is that many a times we write the value for soil metric potential. Coming back, first component, soil metric potential. Sometimes we write it as soil metric suction. Sometimes we write it as soil metric tension. Now this is very confusing for the students, whether it is soil metric potential, suction, tension, but let me tell you, all these three terms are used synonymously. The only difference is, if you want to mention the negative value, then you will have to say soil metric potential. I say that soil metric potential is minus 400 centimeters. If I say soil metric potential is 400 centimeters, this will be wrong. If you are saying potential, then you have to use the negative sign. If you want to write soil moisture tension, then don't use the negative sign. 400 centimeter. If you want soil moisture suction, again you have to is that clear? Then this suction potential, tension, metric potential, it is measured by an instrument which is called tensiometer. Very simple instrument which gives you the value of the negative energy or the force with which water is held in the soil. Then gravitational potential. This can be simply measured by selecting a reference point. Now there might be a question in your mind that, sir, this soil is completely saturated and water is flowing freely in all the directions. So in that case, why should we say that water force with which water is held in the soil? Then in a saturated soil, this metric potential, this becomes equal to pressure potential. We call this as pressure potential. And this is always positive. And this is made by an instrument which is called piezometer. So piezometer is simply a tube which is inserted into the soil, having 1/3 of its length being perforated. So water enters from all these perforations, and ultimately water rises like this. And the level of water over here, this gives us the pressure potential value. Based on this, we install the tube wells. The concept of tube well is based on positive pressure potential in a saturated soil, what we call as pressure potential. But when it is unsaturated soil, then it is always soil metric potential. So this is the concept of soil metric potential. I hope it is clear. You can see this repeatedly. In case of any question, you can just give me a call and I'll explain you the things. Thank you very much.